topic from Python. Is my voice is clear? Please give me a thumbs up if my voice is clear. Everybody can hear me. Is there any network issue or any lagging? Perfect. Very good. All right. So we are going to start today's session. Today we will be learning about higher order functions. Higher order functions. Now, what is this? Let's try to understand. I will directly open my Replit and we will just understand this by seeing a code. Is my Replit visible to everybody? Okay, perfect. Thank you. So today we are going to study about map, filter, and reduce. Now, what is this map, filter, and reduce? So these are basically higher order functions in Python. Now, what is a higher order function? Can someone answer? What is a higher order function? Don't worry, to be right or wrong. Function. Okay. Voice okay? All right. Now, how about now? Can you hear me? Okay, perfect. So let's see what is map. What exactly is a map? First of all, I'm going to create a function which is just going to calculate the cube and it will just give me the answer. So the name of the function is cube. I'm going to pass x here in the arguments. And this is going to return cube of x. So let me call it and print the result on the screen. And I'm going to pass the value 2 to x. So that is the output which we get on the screen. Simple enough. It's nothing. We have created a function and it is going to return the cube and we have just called that function. Okay, so this is a normal function which we have studied. Now, the next thing, I'm going to create a list here. L equals to, let's create a list. So I'm just going to write some values here. Okay, this is the list I have created. Now, what exactly I want to do? I have found out the cube of 2 here, right? Now, in the list, I want to find the cube of each and every element and make a new list. Okay, so let's create a new list here. New L. I'm going to name it as new L. You can give any name. So that is an empty list which I have created. All right. So I will be just using the for loop because I just need to do the iteration on the list. So I will use for item in L, and then I'm just going to use the append. So new L dot. All right. It will do the cube of the items, and then it is just going to append in the new list. All right. Now I'm just going to print the output on the screen. All right. Let's see the output. So this is the output. What it has done? It has just done the cube of each and every element, and it has given a new list. Okay. Able to follow this much? Is it clear? Okay. All right. Perfect. Now, this is one way. Now, where is map in this? Perfect. Thanks for the thumbs up. Now, where is map in this? We are just going to study about map function. This is just a normal function which we have used. The normal way. What does the map mean? So what I'm going to do, instead of just writing this way, creating a new list, using the for loop and using the append, I am just going to use another way. So I will comment this out, and I'm going to use the map function, which is a higher order function. Now, what is a higher order function? I asked this question. You can pass a function as an argument to another function. That is called higher order function. Okay, simple enough. Let's see how we can use the map here. New L I'm going to use, and I will write map keyword, and inside the brackets, I'm going to pass the function which I have created here. So let's write cube. The name of the function is cube. So I'll first write cube, comma. Then I'm going to write the list. The list is n. Okay. Let's see the output now. So here, what's happening? Now I have used the map function here. It is returning a map object. It is going to return a map object. Now we have not got our answer perfectly. So we just need to convert this into a list. So let's convert it. Simply, I'm just going to write here list. Now let's see the output. Okay, there you go. We got the same output, which is cube of each and every element present in the list, and it is giving us a new list. This is the purpose of using the map function. Now map is basically a higher order function, because what I am doing, I have just created a function here which is cube, and inside another function I am just passing cube, passing function to another function. So this becomes a higher order function. So instead of just using the normal way, creating a new list, using the for loop, using the append, we don't have to do all those. This can simply be done within one single line using the map function. I hope this makes sense. Yes, no, maybe. Perfect. Thank you, Manjul, for your response. And thanks, Sachin. So that's about map. Now, next one is filter. Let's see the filter. Okay. Now, what do we understand by the word filter? In our kitchen, there is a filter, it's going to give us pure water. We just put in the dirty water inside the filter. It is just going to take out the dirt and it is going to give us the pure water. So similarly, the same analogy you have to use here in Python. Now, it is just going to filter something and it is just going to give us some results. Okay, so I will just write here. I will write the comment. Oh, this is map. Next one is filter. Let's see the filter. Let me create a function. I'll simply name it as filter underscore function. It is going to return if a greater than 4. This is a condition which I have applied. So any value which is greater than 4, that will be returned. Okay, another list I'm going to create here. I've just used the filter function here. So I'll just write the keyword filter and then the name of the function here, which is filter underscore function, comma, the list, which is L. I have just redefined the list here. So that I'm just going to write here. Okay. All right. Let's see the output. There you go. Now, what this is going to do? This filter is also going to return a filter object. Like how the map returned a map object, here you are going to get a filter object. So what you need to do? Simple, like we did here, we just converted that into a list. Simply here also we need to convert this into a list. Okay, so that is the output. In the list, we can see these are the items 1, 2, 4, 6, 4, and 3. Now, what is the condition we have given? A greater than 4. Now, what are the items which is greater than 4? Only 6. Only 6 is there. So it gives us the output as 6 in the list. Able to understand? Perfect. Thank you, Rashmi. So that's pretty clear. Okay, now what if I write a greater than 2? What will be the answer? Perfect. So you can tell the answer, Manju. If it is greater than 2, what will be the output? You can calculate. You can take your time. 4, 6, 4. Okay. Any more answers? 463. All right, very good. 3, okay. All right, that's nice. Everyone is responding. Let's see the output. 463. Okay, Sachin. So let's see the output now. So that is the output. Yeah, very good, Ashish. That was a really nice try. You gave the response. So this is the correct output. 464 and 3. Because greater than 2, you can see 1 is not qualified. So we can't take 1. 2 is also not qualified according to this condition. So the remaining elements, which is 4, 6, 4, and 3. So that is the output. Now, what's happening? Initially, this was the list. Some filtering happened and we got some other output. So we just applied this filter. That is the filter. And eventually, like how does the actual filter which we use in our kitchen, we got the pure water. So this is the extract which you got. Perfect. So this was about the filter. Now, next one is reduce. We are going to learn about reduce function. Okay, we use the map, we use the filter. Now, for the reduce, you have to just make a slight change. First, we have to import the reduce and then only we can use it. That's a rule you have to follow. So I'll directly comment all of this. Okay. One more thing I just wanted to convey. Okay, I'll just take that later. Let's see the reduce here. So first of all, I will just write, I'm going to import the reduce. So from func tools, import reduce. And I'm going to create a list here. And then I will just find out the sum. Sum equals to reduce. I'm just going to use a lambda function here. Now, previously we have studied about lambda function. So instead of creating a separate function, I will directly use the lambda function. Lambda x comma y, x plus y. It's simply going to add the values x and y. And then I will just, so here I have just mentioned the lambda function. We can also plug in a lambda function directly. No need to create a function separately. You can use lambda function here. Now, I will just mention the number, that is the name of the list. Now let's see the output. So there you got 15 as the answer. 15. Now this got reduced to this. That's why the name reduce. Okay, so what's actually happening here? Let me just copy that list. So first of all, this lambda function is applied on this list. So here first it takes x and y. So the first value x and y is 1 and 2. So it is just going to add both of them together. 1 plus 2 will be 3. Okay, next 3 plus 3 will be 6. Then 6 plus 4 will be 10. And then 10 plus 5 will be 15. There you go. That's the answer on the screen. 15 is the answer. So we have just used this reduce function here on this list, and 15 is the answer. Clear? Okay, very good. I hope you are practicing along with me by writing the code also. It's very good that you're watching the session and you are able to follow. Please parallelly write the code along with me. I will just give time of few minutes here. We will just take a short break and then again we will continue. So I will stop sharing. Meanwhile, you can just finish your code. Okay, perfect. Let me share again. Now, what we are going to do in the map, we are just going to plug in the lambda function. So I'm just going to comment this out, the normal function which we have created. And this is the list. Now, I'm not going to use the normal function here. So I'll just remove this cube and I will use the lambda function. Lambda. And what it is going to do, it is going to give us the cube of every element. So I'll just write x and then x into x into x. Okay, let's see the output. This was the output, the previous way using the normal function. Now let's see the output. So you get the same output, which is 1, 8, 64, 2, 16, 64, and 27. So this is also another way using the lambda function directly. Instead of creating functions separately, directly we can use the lambda function. Okay, so this one thing I just wanted to take. So I just explained that here also in the reduce, we used this, and here in the map also we have used this. Perfect. So this was about map, filter, and reduce. Oh, okay. Now there is one more concept which we have to cover today, which is the difference between is and double equals to. Now both of them are comparison operator. Now what is the difference between the is and double equals to? Let's see. So what I'll do, I will just create two variables. A equals to 4. I will use the keyword is, B, and in the next one, I'm going to use double equals to. Okay, let's see the output. So you got the output as false. False and false. Now, why did we get this output? What exactly the is doing? It is actually comparing the location of the object in memory. The location of A and B. So definitely they don't have same location. This is an integer, A equals to 4 and B equals to 4 is a string. So they don't have same memory location. So this will give the output as false. So the is going to compare the memory location. Do they have same memory location? If they have same memory location, then the output would have been true. But here there is something different. And comparison operator, we know it is just going to compare the value. So the value is also not same. This is an integer and this is a string. So again, you get the output as false. So this is the difference between is and double equals to. It's a very important question, very often asked in interviews. So, sometimes we just, know all the complex things, but the very basics, we are confused with very basics. So we should not take it for granted. We'll see that. So the basics should be clear. It's a saying that, whenever you find things difficult, stick to the basics. If your roots are very clear, if your roots are very strong, eventually your plant and tree will be very strong. Now, the next example, which we are going to see, let me just change this to a list. So I'll just write 1, 2. Okay. Let's see the output now. So here the output is false and true. Now what's happening? They don't have same memory location. So answer as false. But the value is same. The list is the same. So for double equals to, you'll get the output as true. Okay. Is for the memory location. Double equals to is for the values. Pretty clear. Now the next one, we will just change the value again. What I'll do, let's keep this one as 3 and 3. Can you tell what will be the output? See, I'm just doing this so that we can interact with each other. It should not be only one-sided. If you are also giving some response, this makes it very interesting. False and true. Okay, Damayanti. False, true. All right, Rashmi. True, 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 true. Okay, Manjul. Amazing, amazing. Perfect, perfect, Sachin. Let's see the output. So we are just going to click on run. There you go. It is true and true. So both of them are going to give the true. Now, why? Why is this the output? Now here, what's happening? Here, both of them are 3. So what Python is going to do, it is not going to create an extra memory location because both the value, it's a constant. Yeah, correct, Rajiv. It's a constant. It's an immutable value. So Python is not going to waste another memory location to, store another value for the P. The memory location will be same. So that's why for is you are going to get the output as true. Both of them have same memory location. So that's the output true. And also both of them have the same value, which is 3. So that is the output again as true. Okay, one more thing. Let's make a final change here. I'm going to write a string. Let's see the output. So for this also we get true and true. Same logic, Python is not going to waste another memory location. So both of them have same memory location and also the value is same. Hello is a string, hello is a string. So you get true and true as the answer. Perfect. So this was about difference between is and double equals to. So we will just quickly revise what we studied today. We studied about higher order function, which is map, filter, and reduce. Okay. We saw its syntax. We can also plug in a lambda function. So that's what it is called, a higher order function. You can pass a function as an argument to another function. And then we studied about is and the double equals to. All right, very good. So thank you so much for attending the session. Kindly stay online. Further, Mr. Mukesh will continue the session and it is going to be very informative. You can ask all the questions on the chat in the WhatsApp group. All the answers and queries will be answered. Now we are going to move forward. Dr. Mukesh, are you there?
Brother Anurag. Thank you.
Thank you, sir.
So,
Yeah.
good evening for most of you in India. Well, good morning for those who are in US as well. So, last week we talked about using different libraries in Python. And we suggested that if you download Anaconda, so you can download anything using pip as well. So does anyone have any questions from last week before we add more information? Were any of you able to download Anaconda? Or did anyone have any trouble downloading Anaconda? Or does anyone know what Anaconda is? Okay. Thanks, Manjul, for downloading it.
Dr. Mukesh, can I say something?
Yes. Are you able to hear me? Are you able to hear me?
Hello.
Yes. Are you able to hear me?
Yes, Dr. Mukesh, can I say something?
Yes, please do.
Yeah. Dr. Mukesh, thank you for giving opportunity to ask the question. Actually, uh, due to my other commitments, I am not able to attend the sessions regularly, but I'm religiously going through the recordings. So last session also I went to the recording and I have few questions based
Sure.
on that. So
Sure.
in terms of Anaconda, yes, I did download it, but I just have one question that I observed that Anaconda also we can just use Anaconda Cloud as well by going
Yes.
to anaconda.cloud and signing in there through our account. So I just wanted to understand that what is the difference between using it on the cloud and physically downloading it and then using it?
Yeah. So practically for us, it won't make much difference.
Okay.
because with Anaconda, you can use Jupyter notebooks, whereas with
Right.
Replit, we are not using that feature. So that was one of the reasons. The only other
Okay.
difference is when you're downloading those libraries, if you have sometimes, many times, what happens is the practical problem is if you're working on multiple projects on your laptop, one project needs Python 2.7 version and needs one version of the library. And if you're working on a different project which needs a different version of Python or a different version of a library, then there's that library conflict. So what Anaconda allows you is to create different namespace, and you can compartmentalize different versions of different libraries so one doesn't override or impact the other. So online also, in the online version also you can do that. But on your laptop, it just gives you more control. That's the only thing. You can do same thing online as well. But if you are, for example, if you have a local database, you want to be able to pull data into a data frame by connecting to a database, and that database is local on your laptop, then it's just easier to do that. Whereas if it's on the cloud, then your database needs to be connected through the cloud, and if it's your local machine which doesn't have a web server on it, then that won't work. So just putting it on your desktop, it gives you more control on what you want to do, but it's not absolute must. You can certainly use the cloud version as well. It depends how you're planning to use Anaconda. So sometimes when we install any software, it gives us the options and we just learn more about how that software works because it asks a lot of questions. So it just gives you a sense of comfort that, yes, I know how I downloaded Anaconda. I know what comes along with it, so you can play with it better. But that doesn't mean you can't do the same if you're using the online version.
Yes, yes, sure. Thank you so much. I completely understand. Means having it on my machine locally downloaded will give me more kind of freedom to try many things out of
Yes.
it. Uh,
Yes.
my another question, if I'm allowed to ask.
Yes, please do.
In one of the last to last sessions, if I'm not wrong, I heard the recording and we were discussing about Python's main application. There are two aspects. One is data engineering and another is data analysis. You
Correct.
explained it very beautifully, and you said that the Power BI and Tableau are actually very powerful and dedicated data analysis tools. uh,
Yes.
so my question is, when these two tools are already, I mean, gives all the capability to do the data analysis, and I guess even they
Yes.
must be having the user interface as well to create dashboards, then
Yes.
what are the situations that the organization will prefer Pandas library over these BI or data analysis tools, except the fact that they don't want to invest much of the amount in Power BI or Tableau like tools? That
Yes.
was, I was just curious to
Yes.
understand
That's
that.
a very
Yeah,
good question. Thanks for asking
yeah,
that question.
yeah. Thank you.
Because I hope others are very curious in asking those questions. A very good question. So I'll repeat the question so everyone understands it. There are always multiple ways of doing things, right? So one of the ways is I can do data analysis within a reporting tool like Tableau or Power BI. Within Power BI, you can have a Python code snippet or R code snippet as well. But I can do it outside of Power BI or outside of Tableau as well. So the question is, how do I decide when to do it within the reporting tool, when to do it outside the reporting tool? So it's a very good, important question to understand the answer. So there are multiple reasons. One is the memory requirements. Typically, when you have a Power BI or Tableau, you will install it on a server, or nowadays you get the cloud version as well. But just for the sake of discussion, let's say I install Power BI on my on a server. That server would have memory 64 GB, right? Servers have typically that much amount of memory. Our laptop, sorry, 64 a laptop would have memory like it doesn't have that much memory like a server, but still has sufficient amount of memory. I can go as high as I want on the server, even up to 1 terabytes of memory as well. But so nowadays, 16 GB on laptop, 8 GB on laptop is fairly common. But on a server, I would have easily 64 to 128 GB memory, and I can go even high as well. But the practical challenge is it's still limited to the amount of memory on that server. Now you might think, 128 GB is a lot of memory. My laptop has only 8 or 16 GB, so 128 should be more than enough. However, there are many use cases, practical use cases, when even that much amount of memory we could run short of. Because when it comes to big data or large volume data sets, and you're doing a lot of these calculations, like brother Anurag showed a very important functionality today of map and reduce. Why that is very important? Because that has its concepts in big data. So and I'll talk more about it if time permits. But essentially there are many problems in which you have to load the entire data in memory and be able to process it. For example, you're learning a deep learning application or so on. You have to use a lot of memory to do that training and do that analysis. If you do that in Tableau or Power BI or any reporting server, you are actually doing those calculations on that server where that reporting software is installed. So if you use a Python snippet which is working on, let's say, 1 terabyte of data, it's doing all performing all that logic and everything. It has to pull that into a data frame and do all those calculations. At some point you run the risk of running out of memory. So you are limited by how much memory is there on the server which is having the Power BI or Tableau. Now, one might say, well, I'll just go and use it on the cloud. Even when you go and use any software as a service capability, there are always restrictions in terms of how much data you can load, because otherwise you will exceed that memory limit. So there are limitations anytime when you use on the cloud. So even if you were to do it on-prem, you're limited by the amount of memory on that server on which the reporting tool is installed. So if you're doing a lot of calculations which far exceed the memory requirements, the disk requirements of that reporting server, then it's beneficial to do it outside it, right? That's one reason. Second
Okay.
reason is, many times the computing power which is there on that reporting server may not be sufficient, because AI applications, they consume a lot of CPU power. So that's why many applications, instead of CPU, they use GPU as well, graphical processing unit. So NVIDIA has a lot of GPUs, and they do these calculations on GPU instead of CPU, because CPU has a GPU in it, but it does other things. Whereas GPU is dedicated for doing those mathematical calculations. So it's a lot faster than a CPU. So if you have a use case in which you have to do a lot of calculations, and those calculations require a lot of computing power, including a lot of CPU cores and memory, which your reporting server would be limited, because why spend money on a very high-end server which has reporting on it and which is doing these calculations just for that back-end processing? It's better to do it outside of that reporting server, and then give the result of that calculation and visualize it in the reporting server. So when you want to do it outside, the other advantage is you can do it in a distributed computing, or you can do it in a cluster. So cluster is nothing but a collection of each node or each server in a cluster. In a group of servers, we call it as a cluster. So instead of doing my calculation on one server, now I can distribute that calculation on a group of servers, which is a cluster, which gives me a lot more computational power to do those calculations. And AI calculations can become very heavy. As the size of the data increases, the number of calculations go up. So in that case, you need that computing power. And that computing power, you can use it using Databricks or Snowflake, and those are on the cloud as well. And you can install Apache Spark, but they are on cloud as well. You can define how big cluster you want, how many nodes. Each server is a node, so how many nodes you need in a cluster, you can define that. You can write your Python code in a Jupyter notebook, and you can run that processing logic, your deep learning logic, your linear regression, or whatever Python analysis that a data scientist needs to do. You can do that in a distributed computing environment in a cluster, which means you're parallelizing implementation of that logic. So that way you can do it a lot faster. You got a lot many resources, and the outcome can then just go to that reporting layer or that reporting server to visualize better what the outcome is. So in that case, you want to do it outside. But if it's a small company, you are just playing and doing an assignment. And in that case, you can certainly put everything on one machine, not a problem. But typically in an organization, large organizations which want to have that computing power, they will do it separately. So you'll have a separate compute engine which is doing these computations, and you'll have a separate reporting server which is visualizing the outcome of these computations.
Yes, great. Thank you so much, Dr. Mukesh. It really makes sense. I just want to confirm one understanding when we talk about cluster. So,
Yeah.
cluster is kind of a combination of different nodes. Individually, we can kind of name them as small servers, and
Yeah.
dividing the computing between those servers. So, definitely, organization has to maybe they need to invest some extra amount in creating this cluster and then dividing this computing. Is that understanding right?
Yes, yes. So
Okay,
nowadays,
okay,
everything is moving to cloud. So, for
okay,
example, I would strongly suggest those who want to get into deeper into it, try to create a free account. I don't know if they used to do it in the past, but you can see if you can create an account on databricks.com. Or if not,
okay,
you'll have to download Apache Spark. So
okay,
what happens is you can define the size of the cluster and the number of nodes in a cluster. So
okay.
cluster is nothing but a group of servers. Each server
Hmm.
is also called a node. So a
Right,
cluster is nothing but a collection of nodes where each node is a server and has certain number of CPU cores and memory. So if you can have one server with 10 CPU cores and 128 GB memory, and if you create a cluster of 10 such nodes, you got distributed memory of 128 GB times 10, because you got 10 nodes in the cluster. The advantage of building a cluster is it's horizontally scalable. Uh, there are two concepts: vertical scalability and horizontal scalability. In very easy to understand way, since we have time today, I'll take the liberty of explaining the concept of cluster and horizontal scalability and vertical scalability.
sure.
To take the simple example, let's say, I need to create housing for 1,000 people. I have two options, right? One, I can create a tall building which is 100-story tall, and I can try to fit 1,000 people in that 100-story building, something as tall as Burj Khalifa as well, right? I'm
Right,
vertically scaling up. Now, tomorrow, population is growing. I need to house more 200 people. There are limits to how much I can vertically scale. It already has 100 floors in it. Adding two more will be very costly, right? And there are limits to how much I can add. Similarly, I already have a server. It has 10 CPUs and 128 GB RAM on it. There's a limit on how much more RAM I can add to it because it has fixed number of slots, right? But the number of
right,
CPU I cannot add, right? Because the motherboard has a fixed soldered slot on the CPU. The address bus is all connected to the CPU and everything. So I cannot just add a CPU. I can add a little bit memory to enhance the performance of the server, but there are limits how much I can add based on the number of memory slots available. Same for your laptop, right? You can
right.
vertically scale only to a certain limit. You can swap the hard disk, add a bigger hard disk. Maybe you can add a little bit more RAM, but you cannot add more CPU. And how much RAM you can add is also limited. Your model will tell you can only add X amount of RAM. So that is vertical scalability. The next example is, instead of vertical scalability, you can have horizontal scalability. So instead of building a tall building with 100 floors, I can create, I can buy land and I can create 10 buildings with 10 floors in each of them. And if I need more people to put, I need to put 200 people extra, populations growing, I'll create another phase of development and add another complex and add another building. That way, the more land I have, the more buildings I can keep on adding onto it, and I can incrementally add more capacity, housing capacity for the people. That is horizontally scaling, right? I'm growing more on the land instead of growing on the limited land. So I'm adding more and more servers. Each apartment building is like a server. So instead of adding more floors to the building, I'm adding more servers, right? Or I'm adding more apartment complex in my housing community. That way, I'm adding more capacity. So that is horizontal scaling. I keep on add. So horizontal scaling is a lot preferable for organizations because it gives you the ability to keep on adding. As your business keeps growing and growing, you can keep adding more and more servers or nodes to this group of servers, which is a cluster, right? So in this analogy, each apartment building is equivalent to a server or equivalent to a node. The combination of all these apartment buildings, it becomes an apartment complex, which is nothing we call as a cluster. Yeah. So is the concept of horizontal scaling and vertical scaling clear?
Absolutely, Dr. Mukesh.
Yep.
That makes
So,
sense. Yeah, yeah,
so
yeah.
what happens is, to answer your question, when you are doing all these computation, horizontal scaling is preferred versus vertical scaling, because as your data size increases, you're doing more and more calculations, you are enhancing your calculations. There is a need for an environment or an infrastructure which is horizontally scalable. And big data solved that problem, because previously that wasn't possible. So if I look at, what has caused the revolution in AI, it's these big data platforms which came in, where computational power can now be, it's very relatively cheap and it can be distributed. If I look back in the 1990s and early 2000s, how did we do it then? Well, you had supercomputers, and large universities had these large vertical farm of servers, and every few years, every 3 4 years, they would go and replace it with bigger, more powerful CPUs and more memory. That's how they still created a cluster, but it was entirely focused on vertical scaling, right? So in Linux you can create still a cluster, but it's entirely focused on maximizing the specs of each server. And that's how grid computing was done. So before big data came in, you had these massive supercomputers, right? Supercomputing was there. Then, so that's why, in India had its own CDAC, and only large universities, they could perform those calculations. So AI was limited to research organizations and universities as well. We moved from supercomputing to grid computing, where you still had these so-called Beowulf Linux clustered, but each node in the cluster was very high spec, right? So it was still very expensive, and the kind of software that you would run on it was even more expensive. Nothing open source. So the kind of software that organizations ran was SAS, SAS. And IBM had some software, and Oracle had some grid computing software and so on, but very limited choices, very expensive. So that was the primary reason why AI research was limited to universities only, and businesses never used it, because building those grid computing servers, those capacities, was very expensive and cost prohibitive. Not every organization could afford to do it. So that kind of hindered innovation and limited how we can practically use AI machine learning for business applications. In the late 2005-6, in that area, the concept of distributed computing became very much practical, affordable, and easy to implement for organizations. That started with Hadoop. So Hadoop uh, changed the way how we do AI and big data and data analysis. And instead of doing it on supercomputers and grid computers, we were now able to, organizations were able to distribute that data on a cluster. But these machines in the clusters, they were not these high-end machines which are very expensive. They were these normal servers that we would buy, and you would build a cluster out of it. And Hadoop was open source, which means no licensing cost, no need of high expensive hardware. You can build a cluster of even 3 nodes and do your research based on the amount of computational power you need. And Hadoop is nothing but a distributed file system which is highly scalable because it's highly horizontal. So you can keep on adding more and more nodes in your cluster, and you can store your data on this Hadoop distributed file system, HDFS, or short or simply abbreviated as Hadoop. So with Hadoop, you can store massive amounts of data. Massive typically at that time was terabytes and petabytes. You can store that data on this cluster, and that data which was stored on this cluster behind the scenes had multiple nodes in that cluster. And as the amount of data grew, you can incrementally keep on adding more nodes to your cluster. So that way you can expand on that computational power. So that's how Hadoop came in. And with Hadoop came the concept of map and filter. So what Anurag showed today, he was just showing how you would do map and filter in Python. But the concepts for these map and filter, anytime if you study Hadoop, or any data scientist would need to understand this history to better get understanding of where we are and how we got over here. So the concepts of map reduce also were born at the time of Hadoop. Why were these concepts born? What was their relevance? These concepts were born out of the necessity of being able to do calculations in parallel, right? So Hadoop solved one problem saying instead of storing all your data on one file server, right? File server is nothing but a type of storage called network attached storage, or often called as NAS. If you Google for companies like Epsilon, right, you can buy a NAS server where you can store 2 terabytes of data. But you can only store 2 terabytes of data on a NAS server as a file share, right? You can't process a lot of data on it. It's just a file share. So you still need processing capability, right? So there was a need of not only being able to store huge volumes of data in a cluster, but how to process that data in the cluster. And what Hadoop provided as part of that framework was the map reduce capability. So the concept for map reduce is you take a problem which is map reducible. Let's take an example. You've got a file with 100 lines in it. Each line, each row is a sentence, right? And I want to find out how many times the word happy is there in this entire file. Okay, so the problem statement is, for the simplicity, I'm taking a very small file to show the concept how things can be done in a distributed manner or in parallel instead of sequential. Because when you do things parallel, you can do it a lot faster. So the problem statement is, I have a file which has 100 sentences in it, each sentence on a new line. The sentences has different words. I want to calculate the total number of times the word happy occurs in the entire file. Right? Now, one way of doing it, the old traditional way of doing it is read line by line, search for the word happy in it, right? And if you find it, you'll increment the counter. right? But you're doing it sequentially. You go to line number 1, read the sentence in an array. You try to match each word with the word happy, and if that match occurs, you will increment the count by 1. Then you go to the next sentence number 2 or row number 2, do the same, call that same function, see if the word happy exists, and increment the global variable happy counter. And you would do it sequentially 1, 2, 3, 4, all the way till line number 100. That would solve the problem. However, what if I told you I want to do it in parallel? Instead of doing it sequentially, I want to do it in parallel. So one way is you can break your 100 lines, let's say, into chunks of 4, 24 lines, 24 lines, 24 lines. I can create a variable which will read or store those 24 lines. Each of the machine does this calculation of how many times word happy occurs in each of those 25 lines. But when it's doing that calculation, how many times the word happy occurs in each of those 25 lines, I'm doing this calculation on 4 different machines. So machine number 1 or node number 1 will do this calculation, how many times happy occurs in 25 lines. Machine number 2 also does the same calculation. Machine number 3 does the same. Machine number 4. So what I've done is I've taken that same problem, instead of doing it 1, 2, 3, 4 all the way to 100, now I'm going to get 4 counts. Count for number of happy instances and from machine 1, count of number of happy instances on machine 2, machine 3, machine 4, and I can add the total count and get the count. So what happened? Now I took a problem which I was solving in a sequential way, one after the other. Now I solved that problem by running it on a distributed machine or in a distributed cluster and got faster results. In order to do that, what did I do? I first reduced the problem, right, to a small number of data set which can be distributed across the different machines, right? So instead of 100 sentences, I distributed into 25, 25, 25. So I reduced the problem set, and then I computed all those calculations, and then I mapped them back. I added the count of happy counters from each of those 4 into the final happy count, and my answer will be the same as I would have got when it was sequential, right? So this is a map reducible problem where I can split the problem, and the answer would be the same whether I did it in sequential or parallel. And by doing it in parallel, I can run it a lot faster. Now, if it's 100 lines, it won't make sense because, how fast it would be, maybe millisecond, maybe even the same. But if I were to extend this to large volume, to big data sets, right? Definition of big data is big data has 3 V's: large volume of data, large variety of data. Variety of data meaning your data can be structured or relational. Anything that I can open in Excel or any CSV file format is relational data. So because I can open it in a tabular format, I have rows and columns, right? And I can join data from multiple files like we discussed last week. I can process that. So that's relational. The structure of the data is I can relate the data among multiple files by some key, right? But it has a structure to it, has a fixed number of rows, fixed number of columns. The columns define the structure to that data. But data may not always be structured. Your data could be semi-structured. Semi-structured mean it still has some structure to it, but the structure is defined in a separate file. Example of semi-structured data is JSON and XML. So I'm not sure if you've seen a sample JSON file or a sample XML file. I would strongly suggest Google for it, or next time we can show you a sample JSON. What does a JSON look like, or what does an XML file look like? In simple English language words, a JSON is a type of a file which has these squiggly marks, right? And you can define your data in JSON. Similarly, you can define your data through tags in an XML file. And JSON or XML are very good file formats for exchanging information. So when you are exposing your data as a service, right? I think one of the examples we had talked about, for example, yatra.com or makemytrip.com, How are they showing all these different pairs of different websites? They go to each of the website server, make an API call, they get the data in JSON or XML, aggregate all the data and show it on the screen as a summary, and you buy it and make it easier for you. So instead of going to 5 different websites, you can go to one website and see all those pairs. But behind the scenes, it's using APIs and XML or JSON. Most probably JSON instead of XML nowadays because it's more lightweight. But that is semi-structured data. So nowadays, you've got social media data, social Facebook post, Twitter or X feeds now. So all that data is JSON, and you want to mine or process it, right? So in that case, you're getting a lot of JSON data, which by itself, each message is small, but because there's so much data happening, created every second, if I were to accumulate it over a period of time, that volume of that small data becomes large now. So big data includes large data sets, which you get from your systems, third parties, small amount of data which becomes large when accumulated over a period of time, right? So those are some of the examples of big data where you have XML, JSON, you can process that on this platform. So Hadoop uses a map reduce. You can reduce a problem as long as it's map reducible, and not only store high volumes of data on this distributed file system, but also process it. And that's when after that Python became more and more very popular after that. Python existed before big data, but it was more used as a scripting language. But because Python, you can run that code on that big data platform in a distributed manner, Python became the popularity of Python exploded. And then after 2010 onwards, it started trending, and it's the most popular language now. But that time it was trending at that time. So that's the history of how Hadoop was created to store large amount of data sets, and it was cheap, which means organizations could afford it. And Hadoop brought in another concept that because it's cheap, and cheap hardware, cheap relatively, right? So it's not cheap, it's still, each of those server is $10,000, but it's cheaper as compared to the $200,000 servers which IBM was selling as P servers, which had a lot of virtual cores and memory in each of those servers. So relatively, it was cheaper, and it allows you the capability to incrementally add as well. So that's why big data platform became relevant, and you can use map reduce and solve those problems. And then in that big data platform, Apache Spark, which is now managed on the cloud and goes as Databricks, that came. So hopefully this gives you a good background of the importance of MapReduce, what big data is, why do we want to do computation outside of a reporting server and do it on a big data cluster or do it on the cloud so that you can get massive computing power.
Yes, Dr. Mukesh. Honestly speaking, it felt like an enlightenment, to be honest. Wonderful explanation, and I guess it has answered my another question as well, because you also talked about the Azure Factory, the ETL tool,
Yes,
in the last session, and there also you mentioned that it has also a data transformation capability. Then I had a
correct.
question that why then Python within it for transformation, because it already has a transformation capability. But now you answered the question that it is because of the computing power that needs to be distributed so that the single server doesn't get overloaded. So that answered my
Correct.
question while
Yep.
doing this thing. Thank you so much. Yes, yes.
Okay. Great. I strongly encourage, take advantage of this forum to ask questions,
Yes.
because this will just enhance your understanding. So appreciate you asking the question. I would like to encourage others to ask questions or post it on the WhatsApp group as well.
Sure, sure. Thank you so
with,
much, Dr.
with
Mukesh.
that, I think we can have another quick round of mind empowerment technique. So
Yeah, yeah.
Sister
Dr.
Archie,
Mukesh,
you are
if
ready? Yes.
just one question, if we last and simple question
Sure.
regarding today's session only. So, Brother Anurag demonstrated beautifully about that is and double equal to comparison stuff, and there he demonstrated about strings and list. So in the case of strings and integers, it was showing as true, but in the case of list, it was showing false. So I didn't understand. Is it because of the data structure as a list that was coming as different memory location, or what exactly was the reason?
Yeah, so typically these concepts, they arise from object oriented programming. So
Yeah.
essentially, when you have your data type is predefined, string to string we are comparing, right? But if you
Hmm.
are defining your own class, or you're creating an instance of that class as an object, so I'm saying I'm creating a class called car, and the car has a shape, it has color, it has multiple attributes logically put in a class object which I am defining. And then
Hmm.
I want to compare two objects or two instances of those class, and then I want to compare it. So in that case, when I want to say, I have an object called Maruti and I have an object car uh, BMW, let's say. If I want to see if they are equal, then it has to go and compare each and every attribute to make sure they are of the same value. So instead of writing code to compare each and every attribute to make sure they're of the same value, we will overload that operator and we'll just call that function. And then every time when you're checking is equal to, it will go and check if each and every attribute of that class object is the same, then only it will say it. So these concepts are more used when you're defining large objects and everything. It becomes very handy and practical at that time.
Sure. Thank you so much. Yeah,
Yeah, we can elaborate on it in our next session as well.
definitely.
Sister
Thank you.
Raki is waiting. Yeah, thank
Thanks a
you.
lot.
So Raki, if you want to get started. Okay, I think we can Sister Raki's message there. So let's do a round of a mind relaxation technique. So to understand, and you have to experience this, but little bit of theory helps in relaxing the mind. So the way our mind works, everything, what we do, what we say, right? Everything starts with a thought. This is how mind works. Everything. It happens so fast, and we may not be aware, but the reality is everything starts with a thought. And the way our mind works, we get a thought. So we have a thought generator, which is constantly generating thoughts. And then we have a decision maker, which we sometimes confuse the mind and the brain. The brain is just an organ of the body, like the eyes, the ears, and so on. It's our biochemical computing machine, which is taking the enzymes and then actually performing the action of lifting the hand or moving the lips to utter a word. But what to utter, that comes from the mind. And many times we get mixed in this mind and matter complex and becomes very complicated. But it's actually very simple, right? You are the soul which powers the body. The soul is different from the body, right? So the soul has the thought generator, and the soul has the mind, which is taking the decisions. And then it has this deep subconscious, which we call it as the habits, or in Hindi, we use the word sanskar. So thought generation, decision making, or we call it as intellect, or in Hindi, we call it as buddhi. So man, buddhi, sanskar, these are the integral departments or parts of the soul. That's how the soul functions. And and it gives those commands to the brain, and the brain performs the physical action. That's how our mind works. So it's important to understand how the mind works. So then we are in control of the mind, we are in control of the body. So many times we feel stress. You'll say, I've got too much work today. I feel stress. Well, why do we feel stress? Is it the brain feeling stress, or is it the soul feeling stress? Right? In reality, all these feelings, emotions, all these are processed in the soul, exhibited by the brain through the body. right? If the soul is unhappy, depressed, right, then it says, I'm feeling terrible. That command goes to the brain, biochemical reaction occurs, it sends tears to the eye, right? But who's feeling that pain? It is the soul, right? So the soul has three major departments to it: thought generator, decision making, and this deep subconscious mind, or the habits which we call as sanskars. This is essential to understand the working of the mind. So what we'll do is we'll try to experience silence today. What is silence? Silence is not when outside noise ceases to exist, when there's pin drop silence. That is outside silence. What I'm talking about is the silence of the mind, where even though outside it's noisy, but inside you feel silence. That is true silence, right? Outside noise, I may or may not be able to control. I can shut down all the windows, but still, then someone is going to press that horn and break that silence. But the inner silence, I have control over it, and we can experience that silence right now. How do we experience it? It is through funneling or controlling the quantity of the thoughts. So, in the mind, everything that happens starts with a thought, right? How do we create these thoughts, or what is the basis of creating thoughts? So, one is through our bodily organs or the senses, sense organs. If I see something, right, I'm going to create a thought, right? For example, right, if I see the picture of Saraswati, what thought am I going to get? Try it, right? Close your eyes, see the picture of Goddess Saraswati, right? You can visualize it. She has that veena, and she's wearing that white sari, and she's smiling and wearing that veena, and she has the veena over there. So you see that, right? What thought did you create? She's the goddess of education. You want to study, you become very serious, you get that thought. If you see Ritik Roshan, what thought you're going to get? You want to feel, you want to dance, you want to watch a movie. So what you see influences what thought I get, right? So our thoughts are dependent on what you see, what you hear, what you taste, on the sense organs, right? So they impact how we think. That's one way. Second way, what how we think depends on our past memories. Okay, so do this experiment right now. Think of a past moment when you were the most happiest. Close your eyes, think of a past moment. Doesn't matter how many years back, could be recent, could be many years back, but you were the most happiest. Think of that memory, try to recollect that memory, and tell me, or tell yourself, what thought did I get? So if your thought was a happy, if your memory was a happy memory, based on that memory, even if your eyes are closed, you're not seeing anything with your sense organs, you created a thought. That thought was so, that memory was so powerful, impactful, it created that impactful thought. That thought had so much power that when it came to your mind, it recollected that and it felt happy again. Did anyone who recollected that happy memory not feel happy? Please do say, or say, it didn't work. Similarly, if you recollect the most worst memory when someone hurt you, or someone insulted you, or your boss said something, or you weren't happy, if you recollect that memory, how would you feel? You will feel miserable, terrible again, because you recollected that memory. You are empowered. You have the power to choose which memory you want to think: happy memory or sad memory. You have the power. Try exercising that power right now and see, can you control which thought created, and thereby you control the state of mind based on what memory you are replaying. Try this experiment right now. Exactly. As the memory, so the feeling. So, our state of the mind is directly proportional or related to what thoughts are occurring, right? If I see good, I get a good thought. If I see bad, I get bad thoughts. If I have bad memories and I recollect bad memories, I feel bad. If I recollect good memories, happy memories, I feel happy. I didn't have to go and spend to get a Cadbury chocolate to feel happy. I created a happy memory and I'm happy. Right? So, happiness is a state of the mind. Happiness is not a goal that you have to do something to achieve. It is a state of the mind, and our mind always has some state, right? It can very much be possible to be in a default state of happiness for a long period of time, but we don't know how to do that. And then we think happiness is a destination which keeps floating away and away, and it looks like a floating target that we miss every time. But that is not reality. The reality is happiness is a state of mind. We are the rulers, right? The soul is controlling the body. The soul is so powerful, right, that it can control the body. When the soul leaves the body has no value. It starts thinking. It has zero value, right? No matter how powerful the person was when the soul was there. That person could be a big politician, could be a president, could be a prime minister, right? Could be a film star, could be playing any role. But the moment that soul leaves that body, that power is gone. That person's, whether it was a president or a superstar or a film star, has no value. The body has no value. It is the soul that is performing the actions through the body, is doing that karma or is doing those action, has the value. So who's more powerful, the soul or the body? The soul performing the actions through the body is more powerful. Such is the great power that soul can self govern itself and decide how, what levels and what achievements it want to achieve. So the way it starts with a simple thought, and then the mind intellect, and then the decisioning, and then the physical reaction happens in the brain, and we actually perform the action. So what is stress? When lot of thoughts come in a short amount of time, then the decision making capacity, it feels stress, right? So let's say, you've got a lot of work. Your boss said you have to do this today, end of the day. You're something at the house, you have to, your mom said or your wife said or your husband said or someone said you have to do this today, make sure you do this before you get home. Your boss said this needs to be done by 5 o'clock, client needs it, plus you've got other bills to pay. Your mind is processing a lot of thoughts, but it's just processing it, not able to take decision on it. Those thoughts are piling up and up. You're constantly thinking about, I have to do this for the client, I have to do this for the client. That thought keeps interrupting you. Someone is calling you, that thought is interrupting you. So when you get a flood of those thoughts in a short amount of time that your intellect or buddhi is not able to process in that short amount of time, or not able to take a decision, we feel stress. We then, even if there is pin drop silence outside, you're not going to feel the silence inside, because that inner voice is constantly thinking and talking and saying, I need to do this, I'm so stressed out, I have to do this, why do I have to do it, why only I have to do it, why can't he tell him or her the other thing, why Why does it always has to me? That tape inner mind, that inner voice keeps going on and on. Each of that inner voice is nothing but a thought, and those flood of thoughts, it's like a hurricane. It blows your mind, reduces the capacity of your decision making of the mind, resulting in just pure stress. I don't think we have to practice that because you already experienced it, right? But this is the mechanism of how stress is created. The reason why we are learning this is to how to de-stress ourselves, how to use this knowledge of how the mind works to be able to take the control back and de-stress ourselves. So the first technique is to reduce the quantity of the thoughts. When too many cars come on a busy road, on a small road, it creates a traffic jam. Exactly the same way, too many thoughts come to the mind, to the buddhi, and then it creates this traffic jam of thoughts and it creates stress. And then each of the car is pressing the horn saying, you move along. Nothing move alongs because there's a log jam. Same thing happens in the mind, and the mind feels cluttered. The mind feels confused. The mind feels, like, I don't know what to do. We are not able to take decisions, and then that stress carries on and on. So now that we know how the theory works, how to de-stress it. So step number one, reduce the quantity of the thoughts. How do we reduce the quantity of the thoughts? Well, you can say, yes, I've got three things to do, but I'm going to prioritize and I'm going to do one thing at a time, or I'll do two things at a time, but not more. Rest, I will do it with a calm mind, right? So first you have to calm the mind, right? You, as a traffic cop, you'll say, okay, there's a log jam. Okay, everything else stop. One side of the street, you get priority, you go and finish. Then I will go to the next one. Exactly the same way, you have to prioritize and you'll say, okay, let me manage the control of these thoughts. I will prioritize what is important, and I will focus on only one or two things and get that sorted out. Because many times when we are stressed, stress actually doesn't do work, it reduces your capacity to do work. So by prioritizing and by reducing these traffic of thoughts, you have to tell yourself, you have to create a powerful thought. It's okay. I know how to handle stress. I've handled it before. I will handle it again, but with a calm mind. I'm not going to be agitated. I'm not going to shout and yell at others and complain others, but I will do it with a calm mind. Because when your mind is calm, it's regulating the number of thoughts. Instead of taking those four thoughts and repeating again and creating another 40 thoughts, you are focusing on what is important. You're keeping rest parked aside. You're saying, okay, it's okay, I'll do it later on. You calm the mind and say, I'm just going to focus on one thing. Let me focus on one thing. I'll do my best and not worry about the outcome. So now you reduce the flow of your thoughts, right? And now you're able to focus better and solve it. So when you reduce the number of thoughts, you're reducing the amount of level of stress, which now re-enables your mind to take better decisions and be able to come out of that situation. But that still does not make you experience silence, inner silence. To experience inner silence, you have to increase the spacing between the thoughts, right? So I've got thought number one, boss said I have to do this by 5. Thought number two, I have to get groceries from the market before I go home. Thought number three, I have to pay bills. Thought number four, how am I going to do it? Thought number five, why I have to do it. All those ways thoughts compounded my core thoughts, which were actionable, right? So I created more stress by adding wasteful thoughts. To control my mind, first I have to get rid of all the waste. These thoughts, why I have to do it, they're not relevant at the moment. Maybe they are relevant, but that's post-mortem. When the task is done, you can say, okay, why is it that I have to do? Can I delegate it to someone, or is a better way? Can I pay my bill online? That is post-mortem. But right now, you need to focus on actually doing the work, focusing on that thought instead of adding those wasteful thoughts, right? So you reduce the number of thoughts to the what is actually necessary. But to experience silence, you add moments of silence between the thoughts, right? So let's experience it. So I'm going to give a powerful thought to myself that I am going to be happy for the next 2 minutes. No matter how much stress I have in life, no matter what the situation in life is, no matter how much depression I'm going through, I want to be happy for the next 2 minutes. I set that goal because I am the master, I am the controller, not the body. The brain doesn't decide whether I am happy or sad. I, as the soul, decide I want to be happy, calm, stress free for 2 minutes. That's a decision, that's a choice that I make. So, how am I going to experience that silence? First, I'm going to silence my thought process, where a lot of these silence, I'm going to silence them. One easy way to silence it, always keep the perspective in mind. If I were to die today, would all of these things matter? What, who's going to do the groceries? Who's going to do the job before 5 o'clock? In the big picture, does it matter? No. The mind might say yes, right? If I don't bring the groceries, how will food be made? If you don't make, Swiggy is there. They will order it from there. Don't worry. So, what is important for you? You focus on the most important thing, which is your happiness. So, cut down all those thoughts, right? Try to create only one thought, that I am powerful, I have the right to be happy, and I'm going to generate happiness. I am going to be happy. You create that thought. You create this thought and then try to be silent. Don't create another thought. Your mind at first will try to create another thought and say, how, I don't believe this, right? Don't go into that. Experience that gap between the thoughts. The more the gap between the thoughts, the more the inner silence you experience. But the mind has become accustomed to drifting. You start with that one powerful thought, another thought will come in. So create that thought, stay in silent, then reiterate that thought. Now you've reduced the quantity of thoughts, no stress, and you are able to create happiness with that powerful thought. And you're also able to experience inner silence by not allowing other thoughts to come in between and reiterating that powerful thoughts every time another thoughts try to come in. So let's try that. Sit that in silence for just a minute. Observe your thoughts, right? Don't act on them. The mind is rebellious, right? It will try to do if you force it. So just say, the reality is I am in control of myself. I always am, no matter what I'm made to believe. But I'm going to exercise that control over myself starting this moment now. I am a powerful soul and I choose, I make that decision. No matter what happens, I am going to be happy. Stay in that thought. Coming back to the present moment, even this few seconds or moments of silence and you observing your thoughts and trying to assert your control over the thoughts, this gives you an experience. Even if it is very short lived, that's perfectly okay. But this experience becomes a memory. So next time when you are stressed out, remember that you did an experiment where you took control over your thoughts. You decided to take control back and be in control of the situation, and you can create that small millisecond or second of happiness and silence. This experience you can then expand to, and even though you're in a stressful situations, you can practice this for even 5 seconds. 60 seconds is even long. Even if you can do this for 5 seconds, 10 seconds, or increase that duration, it would make a difference. But no matter how much I say, this is something that you have to try and experience. So I don't know if any of you were able to experience or share that experience for the benefit of others, but this is something that needs to be experienced instead of describing it in words. If your mind is drifting, reiterate the thought: I am a powerful soul and I choose to be happy. Okay, coming back to the present, I hope limited, no matter how short, this experience will help you carry forward. And the more you practice, the more you'll be able to assert your authority and control over the mind and how the mind works as well. Thank you very much. Have a great weekend, all of you. If you have any questions, you can always ask questions. If you want to share your experience, you're most welcome to share. Thank you again.
मेथी का दाना पिए, फिर मेथी के दाने को चबाकर अपने और इसके बाद कृपया तुरंत पानी पिए। आपका गैप पाहिजे थोडं। आपकी शुगर कंट्रोल दिन में कंट्रोल करेगी, दिन में